Hello, this video demonstrates a complete implementation of a public key infrastructure for the secure communication and cryptography module. The objective of this project is to demonstrate how PKI is used to secure HTTPS communication, how digital certificates are issued and trusted, and how man-in-the-middle attacks are prevented when the trust model is correctly implemented. In this project, we create a root certificate authority and generate and sign certificates, deploy HTTPS on a web server, and demonstrate both unsuccessful and successful man-in-the-middle attack scenarios to evaluate PKI security. The system is implemented across three separate roles: a certificate authority, a secure web server, and an attacker, each operating on a separate systems to reflect a realistic PKI deployment. This video focuses on demonstrating the working component of the system beginning with the certificate authority and certificate verification process. So when I pay, so this directory contains the certificate authority environment, and it includes separate directories for certificates, private keys, and certificate metadata following the OpenSSL best practices. And then if you and this private directory contains the root CA private key, which is the most sensitive component of PKI and is protected using strict file permissions. And in here, and we can see that this is a self-signed root certificate authority certificate. This is self-signed root certificate authority certificate, and this certificate inspection confirms that the basic constraints of the basic constraints convention is set to CA colon true, which authorizes the certificate to issue and sign other certificates. The issuer and the subject fields are identical, confirming the this is the self-signed root CA certificate, and this certificate acts as the trust anchor for the entire PKI. The RSA parameters, if you can see here, oh, the RSA parameters including the modulus here, modulus, and the public exponent are embedded within the certificate, while the private parameters remain securely stored in an encrypted key file. Here you go. And this is a certificate signing requested by the web server, and the CSR contains the server's public key and identity information. It also includes the subject's alternative name, which is required for modern HTTPS deployment. The CSR is validated before signing to ensure the correct domain name and cryptographic parameters are present. And this is a server certificate issued by the root certificate authority, and the issuer field confirms the certificate was signed by root CA, and the subject field identifies the web server. This certificate is later deployed in the Apache web server to ensure HTTPS communication. Once the Once deployed on the web server, this certificate allows the HTTPS to be established and trusted by the client that possesses the root CA certificate. In the later stages of the project, HTTPS is shown to prevent man-in-the-middle attacks when an untrusted certificate is used, and fail when the certificate authority is compromised, demonstrating the importance of CA security. In conclusion, this demonstration shows how public key infrastructure enables secure HTTPS communication through trusted certificate authorities, and the project highlights both the strengths of PKI in preventing impersonation attacks and its critical dependence on the security of trust certificate authorities. This concludes the working demonstration of my PKI implementation.
My name is Ankitha, and my responsibility was to generate a certificate signing request and also to obtain a signed certificate from the CA and deploy it on an Apache HTTPS web server. I will briefly demonstrate tasks 2, 3, and 4. So this is the command that I will be using to explain task 2. Using this command, I can show that I had generated a certificate signing request for the web server, and the CSR, it includes the server's public key, and it also identifies details like country, organization, and also like the common name. And I have also added a subject alternative names like www.a00047214.com and also a00047214.com. This is my student ID, and these are required for browser hostname validation. Okay, and this is the command I will be using to explain how I did task 3. In task 3, the CSR was signed by our internal root CA in order to generate the server certificate. And this output, it confirms the certificate issuer as the root CA, and it also shows the validity period, public key details, and also the signature algorithm. As we go, this one. And also the subject alternative names I added in the CSR. Uh, they are also present in the final certificate. Now I'll be explaining task 4. Yeah, and as you can see in task 4, I I use the Apache to obtain or use the signed server certificate and also the private key. And I verified the HTTPS connection using OpenSSL. You can see as these are the two OpenSSL rules that I used, and they also returned a verify return code of 0, which the screenshot I had included in the report. This confirms that a valid certificate chain has occurred, and the website is now accessible over HTTPS with encrypted communication. And if we go to Firefox, we can see that this is the website. As you can see, this is the website I had used. There we go. Yes, so this completes my role in the PKI project, and I had successfully generated the CSR, and I had obtained the CS signed certificate, and I deployed it on Apache HTTPS server. Thank you.
So I have been demonstrating how public key infrastructure protects users against man-in-the-middle attack and what will be happening when the trust is broken. So I have done it in the two task form, and where the first task is like where an attacker uses an untrusted self-signed certificate, and then we'll be explaining then another task which is compromised certificate authority scenario. So the first task will be commanding this command, which we can see that Apache is actively listening on port 443, which confirms that HTTPS service is running. This will be meaning encrypted communication is technically possible, which will be required for the man-in-the-middle attack simulation. Now the second command is this. So here it is, we can see the SSL certificate and private key generator using OpenSSL. This certificate is self-signed, meaning it will be not issued by any trusted certificate authority. The next command is here we can see the output shows X509 certificate details, the issuer and the subjects are the same. So which it will be confirming that this is a self-signed certificate and therefore not trusted under PKI. Next we will be going to the Firefox, and we can see when accessing the HTTPS site, Firefox will be immediately blocking the connection and displaying a warning protect potential security risk ahead message. The browser identifies that the certificate is not trusted and shows the error Mozilla error self-censored. Now, the reason why the browser blocks it is because even though HTTPS encryption exists, the browser cannot verify its authenticity of the server because the certificate was not signed by the trusted CA. This demonstrate like how PKI protects users from the man-middle attacks and by refusing untrusted certificates. Now, when we are coming to the conclusion of task 1, it will be proving that HTTPS alone is not sufficient. Trust will be established only when the certificates are validated through PKI. Now, the next the task is was the MITM with the compromised certificate authority. So it's like uh, it explores more dangerous scenario where a certificate authority itself is compromised, and in this case an attacker could issue certificates that appear completely valid and trusted by browsers. So in this task, like in the previous task, the attack failed because the certificate was self signed and untrusted, but in this task we can say that if a compromised CA issues the certificate and the browser may not show any warning at all, allowing the MITM attack to succeed silently. So, a compromised certificate authority breaks the entire PK trust model. You cannot rely on the browser warnings anymore. This can be led to credential theft, data interception, and impersonation attacks without user awareness. So, in conclusion, I can say that I demonstrated the PKI is the backbone of secure web communication. Also, while PKI effectively blocks MITM attacks and using untrusted certificates, a compromised CA represents a critical security threat. This will be highlighting the importance of certificate validation, revocation mechanism, and strict CA security. Thank you.